Some scores are driven by underlying questions. If a question has a correct or incorrect value, that can establish scores for, say, total correct. One of the unique scores that we have in the system is a standard deviation scorer. For those not familiar in math, that's really trying to say, how far away from the mean are you? Are you extremely far? Are you extremely far on the good side? Extremely far on the bad side? And that would be expressed in terms of standard deviations from the mean. This can be used in scoring to determine disparity from an average score or something like that. So we'll just call this SD score. If you don't ever have to deal with this, I would not be surprised, but at the same time, it's available to you. One of the unique things about our standard deviation scorer, these are standard features, it can be rounded to the nearest decimal places, is you can do standard deviation for questions, or you could do standard deviations for existing scores. So imagine you say, here's a norm score that I would expect out of this test taker, and here's what they got, and I want to establish some sort of standard deviation. I could do that against scores. So I'm going to take just a couple of example values and say, those are what's going to drive my standard deviation score. You'll know this if you need it. The one nuance of this is standard deviation type. And there are two types of standard deviation, of a population or of a sample. And I'm going to get real dorky on you here. And here's what drives it. So if you know every single value of the population is included in this, you have like the census of the United States, you could not possibly have every single value. But if you have a classroom, for example, and all you're trying to calculate is a classroom, you would use the population. You have everything. If you're taking a subset, or you know this is a sampling of something much larger, you would use the sample type. And the only difference in this funky looking mathematical calculation is that you subtract 1 from the denominator when you're summing up those values. So we put on our form that standard deviation of a population is more common because it's based on an actual set of values versus the sample, but feel free to use either type. So standard deviation score, it's a complex score. It can be based on items, it can be based on scores, and you can calculate it based on a population or a sample, and the right-hand side drives what you're calculating that standard deviation score from.